called theta equals pi over 2 axis. Okay, those are the two axes in the polar domain. And the graph that we drew has a symmetry. It's got a symmetry about this line here, about this line here. Because this part of the graph can be folded over onto that. So if you were to take a piece of paper, graph this and fold it over this line, the two halves are going to overlap. The two halves of the circle are going to overlap. That's why the graph that I drew earlier is symmetric about the line theta equals pi over 2. In addition to that, we've got two other symmetries. Get that down, and then we'll graph them and see what that means. Okay, what does it mean to say that the graphs are symmetric about polar and about the pole? Where am I? The first one we already did. Is everybody all right on that? The first one we already did. That's the circle that we just drew. And that's symmetric about the line theta equals pi over 2. So get your graphing calculators out and do the next one. In this case, it's symmetric about the polar axis. Do you see that? Because here's your polar axis. That's your polar axis. This part of the graph, if you were to bend the paper over the red line, would fall onto this part of the graph. So it's symmetric about the polar axis. Okay? So you can think polar axis is like x-axis, theta equals pi over 2 is like y-axis. You guys with me on that? Yes? Either? Okay, you understand symmetry? Okay, one more. Next one is for sine 2 theta. And isn't that sexy? It is a butterfly indeed. So now you know how to do butterflies through graphing. Now this one's got a lot of symmetries, okay? The one that I'm trying to demonstrate to you is the symmetry about the pole. So what does that mean? That means that if you are to go from the pole and you draw a line and then extend the line in the other direction, it'll also fall on the graph. You guys see that? So do another one. If I draw a line from the pole to a point on one leaf, and if I extend the same line, it's going to fall on the other side of the leaf. Yes. So this is symmetric about the pole. Where else is it symmetric about? Fantastic. Awesome. Where else? Polar axis. So it's got symmetry of all kinds. All three kinds it's there. Yeah.
So so you know where you have the red? Like those two leaves weren't there, would it still be, wait.
Then it would, yes, then it would still be. So in other words, if it was something like this, something like that, more symmetric than that.
Yeah.
Yeah, then it would still be because you can draw a line like that.
Okay.
Yeah. Because there's nothing to draw on this side here. Yeah, good question. But if it was something like this, then it's not symmetric about the pole.
It's the polar axis.
It's only the polar axis. Good, awesome, fantastic. Good job, girl. Good job. Okay, is everybody all right on that? Okay. All right. Last topic. Finding min, max, and zeros of polar functions. How many people remember the cosine function? Cosine function. Can anybody come and graph the cosine function for me? You want to do it, Sharik? You're kind of doing it in the air. I think you went in the right direction. What?
Oh, is that the...
Yeah, starts up at top. Myra, you want to come up and throw it on the board? Okay. Functions. And like Myra drew it nicely, it's looking like this. This is 0, pi over 2, 3 pi over 2. Oops, my bad. Pi. 3 pi over 2. And then the last one is 2 pi. Okay? So I want to find out where this graph is going to be the max and min. Okay? Here's my maximum, right? This is a 1. Here's my minimum. That's a -1. Okay? So it's going to be a minimum when the angle is pi. Which means that, remember, this is your angle. Theta is not your angle. It's 3 theta. 3 times that. Okay? You guys with me on that? So your minimum is going to happen at r is -1. Sorry, -2, my bad. Do you see why it's -2? Because of this 2? Yeah? So it's -2. And your angle is going to be pi over 3. Because remember, 3 theta is pi. So theta is equal to pi over 3. Okay? Guys with me on that? Where's the max happening? What's the maximum R value? 2. Where's the max happening? 2 comma. What's the angle? 0. Where else? Nice. Good job, Ian. 2 pi over 3.
Why is it over 3?
Because 3 theta is 2 pi. So then theta is 2 pi over 3. Okay? And when is this guy equal to 0? In other words, r is 0. Yeah, I don't mean theta is 0, but when is r equal to 0? So this means r is equal to 0. So 0 comma pi. Nice. Good job, Myra. And 0, 3 pi over 2. Fantastic. Okay, you guys are good. Okay, so what I want you to do is I want you to graph this using your graphing calculator. Tell me the symmetries and tell me the min, max, and zeros of the function. Okay, you guys want me to write that down? Okay, I want you to, 1, tell me symmetries. So you can use your hand box, okay? 2, min, max, and 0. Okay?